Cornelius Koda, the farmer. Those who have been following, we are pursuing our objective of having an A, nothing less, in this paper that is soon coming, Agriculture Paper 2, which is 527/2. Here we are. We want to do our tutorial, our tutorial in this paper, so that we can help one another to achieve the objective. This paper, we refer to it as agriculture, and it is 527/2. Your name should be made easy. This is our objective, and our ambition is A, nothing less. I think let's continue. Let's see what to do. This paper. This paper here contains two items, and the first item is experimental or investigative, like you're seeing here. This is experimental, and by the virtue that it is experimental, we have to do some investigations on a number or a chosen, a selected area that may actually fit in the preference of the nation or the test writer. In this experimental item, in most cases, you are presented with a scenario involving actually a single challenge, and the challenge may be addressing a particular area. For example, in soil science, which we refer to as soil improvement, we may talk about soil pH, we may talk about soil fertility, and in soil fertility, we want to do an experiment or an investigation on fertilizers, or that is in simple terms, or in particular nutrients. There are those that are macro, there are those that are micro. I'm going just to go through because our ambition is very clear. Then in this particular area of soil science or soil improvement, we may be presented with a scenario case which has a challenge related to soil drainage. In soil drainage, in simple terms, we are referring to water retention, and sometimes it may be capillarity of water. I'm going to give more lines on these areas, because these are the areas that I wanted to handle in this particular facilitation. Then, according to test item writer, that person may go ahead and ask you to make an investigation, an experiment on soil texture, or even soil components, and which of them include organic matter, may include living organisms, may include air, water, minerals, and in some cases they may want you to differentiate between organic matter and humus. So, members, I think let us continue. Indeed, sometimes the test writer may choose to actually go ahead and set something on harvests, such as milk, meat, eggs, hides and skins, cereals, grains, legumes, vegetables, and fruits for consumption, to check if they have the right qualities, they are adaptable for consumption, or for planting, especially the seeds, if they are viable and they can be planted. Now, after knowing that this item has a number of complicated areas that the assessor or the test item writer may choose unpredictably, probably depending on the preference of the nation, like I said. So to a candidate and to a practicing teacher or a teacher, what is therefore needed while handling this item? It has minimal challenges, but there might be only one, but calls for a broader view. So the name experimental, number one, it requires you to provide an aim. Give the aim, which aim describes the purpose of the experiment. indicating the variables. Then number 2, it requires you to give the hypothesis. Hypothesis, I normally tell you my class that this is actually a prediction. What do you predict from your experiment or from the scenario case? Actually, before you talk about the experiment, just critically think through the scenario, the test item, and then can you predict something? Can you predict what could be challenging? What could be the results in case either the situation persists or in case, okay, what could be the results in case you took responsibility to carry out the practical, the experiment, the investigation. This one, the hypothesis, many times it is two-way. You can give a positive hypothesis or a negative hypothesis. Ahead there is an example. I'm going to show how the two can be awarded, can be scored. Well, the next requirement is you to give. You must mention the variables. They should be very clear. And under variables, there are 3 different variables that we are going to consider here. Number 1, we have the independent variable. These ones are very independent. Yeah, we don't have anything to do with them. We cannot alter anything here. And basically they are inputs. The input, yes, we can manipulate, but they are independent. For example, we are talking about sample A, soil sample B. For you cannot manipulate and say, I will bring soil sample 2. I will bring U. These ones are very independent according to the test item. Then we have the dependent ones, the ones we are going to depend on to prove that our investigation is true and there is a challenge. The one you base on to prove that there is a challenge here, therefore your investigation is true and it's giving you a backup of results. And actually these are results in many times. They are the output. We measure them as the produced factor. For example, if you are talking about soil, like we're talking about soil science, in particular soil drainage. And in drainage, we said we talk about capillarity or water retention, the one that other books call as water holding capacity of the soil. And I want you to mark that with a star in your brain because I smell a rat there. So, when you talk about the water holding capacity, what is the dependent variable that you're going to base on to prove to some farmer that this water actually retains more water, or this soil retains more water, and then the other one retains less water or drains water. I mean, you need to consider the volume of water retained. Let me actually highlight this one with red, and I'm not political in that area, though I may love red so much even politically, but at this level I'm not becoming political with this red. The water, the volume of water retained. Then also, we are also going to also consider under the dependent variables, we are going to depend on the volume of water collected, or in simple terms, the volume of water drained in both soil samples. Be attentive. Many times when I'm facilitating, there are these girls of mine. Now look at Sylvia, Rita, Amina. Can you imagine? Process is even dozing. Please pay attention, more especially in this area here. Dependent variables, we are going to consider the amount of water, the volume of water retained. That's number 1. Number 2, the amount of water collected or drained from the soil samples. Both soil samples could have drained some water, but at different amounts, in varying amounts. Then we are going also to consider under the variables, we can talk about the controlled variables. These ones are many times are constants. Some books call it controlled, others call it constants, and they are unchanged factors. For example, okay, these are factors that you keep constant during the experiment, that are kept constant, are kept at K during the experiment. For example, I'm going to give you the example of time. If you're considering 10 minutes for sample A, then you consider the same 10 minutes for sample B. That one becomes a constant variable. Okay, here we have some examples. Number one is the volume of soil used. If you're using 20 cubic centimeters of sample A, then you have to maintain the 20 cubic centimeters also for sample B. That's how it becomes a constant. Then for time, I explained that if you're taking about 4 minutes for sample A to reach the results, then take the same time for also sample B. Well, in this very item, it requires a candidate, a learner, to consider the apparatus or the materials that are required while doing this particular item. And number one material there is the protective gear. You must look at the protective gear. We are going to look at the next slides as we continue, friends. Well, now the learner is highly regarded, is actually highly required to go ahead and list, we cannot say explain, but mention or list the procedure. The procedure, you have to talk about the procedure. And by the virtue of the word procedure is that these are sequential steps. They are order. You have to maintain order. You have to keep order. If procedure number one should be number one, should you put procedure number one to be procedure number 4 or procedure number 10 or 7, then that makes no sense. Your experiment does not really add up to sense. So you have to keep the order of the procedure. Number one procedure for a learner, for a candidate, for anyone doing an investigation, for anyone doing an experiment. Let's pick a leaf from those people of police. When they are doing their investigation, probably there was some murder somewhere, and on the scene there are some materials that would really work out for evidence. They have to first protect themselves against the law, against the case, by putting on the protective gear. So even in our investigative number here, we are going to put on the protective gear. I encourage the student not to only write. Do not only write that put on the protective gear, or I put on the protective gear, I wore the protective gear. No, actually I encourage you to wear it, because this is an investigation that you're going to do practically, not theoretically in the mind. So then the learner will be required to present the data. And many times the data presentation here, I recommend using the table form. Use the table form as you're going to see in the next slides. After presenting your data, please interpret it, analyze the data. In simple terms, explain your findings. Probably if you're talking about soil water drainage, and you're talking about that sample B retained more water, sample A drained more water than sample B, then explain why. Why do you think sample A retained the water, and why do you think sample B, instead of retaining, it drained the water? Mark the two statements, the two terms here are very critical, very crucial. The number one is draining. Draining means losing water, allowing water to go, allowing water to pass through. Draining. Then retaining is holding water, holding it that you don't allow, that these samples, these particular particles of soil do not allow, if they allow, they hardly allow water to go through them. Then your candidate is required also to make a conclusion after the explanation, and you base on the data that you've interpreted there, or you analyze it to give a conclusion. And finally, you need to also show a recommendation. What do you recommend for such a farmer with such a challenge? That's where now the essence of the whole practical is. After showing us the results, what is your recommendation? Therefore, as a doctor, you've now showed that this person has smallpox, monkeypox. Then, therefore, what is the recommendation? But the doctors of nowadays, they say infection. Therefore, what is the recommendation? Infection. And they end on that. Doctors, we salute you. And those who want to be doctors, for us farmers, we see a narrow way to break through to becoming doctors. But it's all possible. With God, you can find a mini mulago as a doctor. But I'll not be that doctor that will always sound infection, but only a doctor to give recommendations. The summary codes for scoring this paper, this item 2 in this paper 2, agriculture practical, number 1 is, okay, to my candidate, how is this one helpful? Make sure that don't leave that number unless if you've talked about the aim. Please talk about the aim. Go ahead and talk about the hypothesis. We are going to show details, the variables, materials, list them, mention the right procedures, do your data presentation in a table way, like we said, interpret your data, explain the data, give a conclusion from what you have investigated, and lastly, give a recommendation. So the people who are called scholars, the examiners, are going to award marks for each and every other area here, starting with the aim to the recommendation. Don't feel comfortable to say, I gave a right aim, but I forgot to write the procedures. Oh, we'll have missed a lot of marks, a lot of scores here. Yet I want you to aim at making an A in this particular subject. Let's continue, members. We want to give the sample expected response. And I'm very intentional on soil water retention. Using samples. For me, I've made sample X and Y. I've extracted sample X and Y, and one sample is coming from Budaka. Then another sample is coming from Chibuku, Kabuna. That's according to me. I'm pretending to be the writer, pretending to be the facilitator, pretending to be the scholar. So here I am. My samples in terms of soil, I'm considering the aim. Members, when you talk about aim, we want you to always start with this paraphrasing. The way you are starting your sentence matters. So now, to me, I recommend start with the word to, because you're giving an aim, you're giving an objective, you're answering why. So why? To determine the amount of water retained by soil samples X and Y. Be very categorical here. Be very particular here. You're going to deal with the samples, not the land in Budaka, not the land in Kabuna, but samples of soils from these particular lands. One in Budaka, one in Kabuna. So it would be very wrong, or it would not make sense to say to determine the amount of water retained by soil in Budaka and soil in Kabuna. Yes, to some level they score it, but I want you to always be really, to show that you have the mastery of the content. Work with samples, because this is just a sample. Kabuna is bigger than a sample. Budaka is bigger than a sample. So maintain the sample identification. If it is X, let it be X. If it is C or D, let it be that as the test item writer preferred. So let me paraphrase it again. To determine the amount of water retained by soil sample X and Y. You are right. Another one may say, to determine the amount of water drained by soil sample X and Y. You are also okay. Another one may say, to determine the amount of water retention or the water holding capacity of soil sample X and Y. You are also very right. Now, that is done. If you have any question, keep watching the video until you get it right, until you find the sense in what I've explained on the aim. Hypothesis. I've minimized my scenario, but many times
we can get the scenario very clearly. I mean, we can get the hypothesis very clearly from the scenario. Let me just cook one scenario here. One farmer in Budaka, also owning land in Kabuna, wanted to plant pineapples. On realizing that pineapples do not do well in waterlogged areas, he considered consulting the pedologists from the area to take measurements, to take experimentation, to take investigations about the lands in Budaka and in Kabuna. And the pedologist picked sample X and Y. So the hypothesis, here, the hypothesis, like I explained earlier, it can be negative, it can be positive. This is just a prediction, and many times predictions may come right, that is positive, or may come wrong, that is negative. To me, if I was a scholar, this would be a very free marker for every candidate, because there is no way you can fail to give a prediction. For example, this one is the Budaka soil sample retains more water than the Kabuna sample. Now, depending on the scenario, because in the scenario they may say that when he planted the pineapples in Budaka, they became yellowish, they were stunted, and they could not grow to expected levels. Their roots were rotting easily. With that statement, you can easily tell that indeed Budaka soil samples retain more water. By common sense, you don't need to go to Budaka, by the way. By common sense, you can get the hypothesis. Read very well the scenario and generate the hypothesis. Budaka soil samples retain more water. Why are you saying that? Why are you making that statement? Basing on the scenario in the test item. Budaka soil sample, when he planted the pineapples were stunted, they were yellowish, they could do, yes, their leaves were easily dropping, lodging was common, the roots were drying, I mean, they were rotting, and eventually the plants could wilt. Then you can identify that, oh, this means these are all symptoms of areas that are poorly drained, that are highly waterlogged. Therefore, this soil sample retains more water than the other. So the negative would be, the negative is actually the vice versa. And it's two ways. One way is vice versa. Kabuna soil samples drain more water than. Can you imagine there is a word than here? Please. Let me even change the color so that I should maintain red. But now how? Let me circle it. Than. It's a comparison, right? You're comparing the retention of water in two different soils. To me, I would think, yes, you're right when you say Budaka soil samples retain more water than Kabuna soil sample. You're very right. But then the whole story would be, or the excellent one would be, Budaka soil sample retains more water, meanwhile, those two words, meanwhile or while Kabuna soil sample drains water. Are you seeing how one is negative, one is positive? Or you can interswitch, start with Kabuna and maintain, relate it to the what? To the master of the subject. If this one is retaining, the other one should be what? Draining. Is positive and the other one is negative. This is, it is retaining one, as you're comparing the two, one is retaining, another one is draining. So hypothesis clearly should be stated that this soil sample now give the location where it is coming from. Budaka soil sample retains more water and connect it to the chronological flow of the scenario case. And then compare. The comparing words are meanwhile or than or while. But let's purpose to use while. I love while more than. Okay. Variables. In this case, what are the variables? What are my variables? Number one, I have the independent variables. Independent. I cannot change. I cannot manipulate. I cannot interswitch. If I'm given soil sample X, it should be X. And if I'm given soil sample Y, it should be Y. I cannot put P, or I cannot design it in my own way to suit my capabilities, which I can pass very well. In that way, I may be setting my own equation. So they are independent. They are independent. Like when you hear Uganda is independent, Uganda can make its own decision. Uganda can stand on its own. So they are independent. Now, the dependent variables, these ones, we look at those ones we really depend on to prove that our investigation, our experiment is really right and can be of help to our farmer. And these are outputs, or other books call it the produced factors. The volume of water retained, the volume of water collected or drained. Remember, we are comparing which one collects, which one drains, which one holds water, which one releases water. So those becomes the dependables. So the volumes, the amounts, we are going to look at figures in soil sample A. How many milliliters did you collect? How about in soil sample B? And then we compare. Are they fitting in the hypothesis we had? We are going to look at that. Controlled or the constants. They can be controlled or constants. For example, time. Probably if I'm given time like I'm going to use 10 minutes. In my procedure, I said I'm going to use 10 minutes. But practically, when I measure the time I'm having to complete the paper and the 10 minutes I'm giving myself in the procedure, it may not really work out well. So I can now control. I say, okay, I'm going to observe soil sample X for 2 minutes as well. Make it constant for also soil sample Y. Let's continue. Members, I'm not going to talk about materials because these ones you have to list them the way they are provided to you and the way you are using them. It is awkward to list a material which you're not going to use. List only those materials that you're going to use and that are really relevant for the practical or for the exercise, for the investigation. Good. Procedure. I will allow you to copy them the way they are. And probably to my people who are not good at sight, those who don't see very well, let me read it for you. I recommend about 7, at most 7 procedures. Beyond that, you are failing. At most 7, at least 6. Number 1, put on protective equipment or protective gear and give justification for safety. Reason for safety. What are you protecting yourself against the samples? Some of them are poisonous, some of them are dangerous, some of them are not human friendly. Number 2, label 2 measuring cylinders X and Y. I think my colleague is going to be doing that. We are going to get a measuring cylinder. Let's see the measuring cylinder. They are here. Let's have these ones. And for purposes of this video, we are going to only do one, so that you use your psyche to connect with the two. And the materials are here. Let's have the measuring cylinder. Let people know the measuring cylinder. Yes, we are going to measure. We are going to label this measuring cylinder according to the samples provided in the test item. Measuring cylinder. Good. I don't know. Then number 3 is plug a funnel using a filter paper or cotton wool and place it on the measuring cylinder. Can we have the funnel? Thank you. We have a funnel here, and yes, this is what we call the filter paper. It's a filter paper box, and in there we have this filter paper. But then we also have the cotton wool. Cornelius, the farmer, is encouraging you to use cotton wool instead of this. Reason being, should you use the filter paper, this is how you use it quickly, because we are working in a time bound. The practical is given actually very limited time, since there are only 2 numbers, maybe only 2 hours. And this is what they are trying to mean, that after now, plug the filter paper. This is the filter paper now in the funnel. Now, why am I not recommending the filter paper? Because the filter paper tends many times to leave spaces between the filter paper itself and the funnel. Filter paper and the funnel. And when you pour water, water has the ability to, it's adhesive, you know that. It has the ability to get attached to the filter surface, the funnel surface, and it will spill through. You may think it is coming from the soil, yet it has actually escaped around the what? Around the filter paper. So this one I'm putting an X. In case you don't have the cotton, you can use it, but it's not really efficient. I'm going to use cotton wool, and in cotton wool, members, I'm going to use a very small film of cotton wool, very small like this. Actually, this is even too big, but for purposes of time, let me use a very small, so that you can even see it down here, trying to block the other channel of the filter funnel. So according to the procedure, we are saying plug the filter, the funnel using a filter paper or cotton wool, and place it onto the measuring cylinder. So I'm placing it on the measuring cylinder. So at the end of the story, this is my setup for the first place in the first 2-3 steps. So again, don't forget the protective gear should be number 1 procedure. I'm repeating, should be number 1 procedure. Master the farmer, why are you not putting it on? I'm giving you a particular facilitation, but it's you to do it, and they will not be there. So this is the setup. Procedure number 4, measure the required volume of soil, sample X, and place it in the funnel on the cylinder. So we are going to measure. Please come here in the camera so that as you're measuring, people know. I'm recommending a particular volume of soil sample. For reasons, I'm going to give you the reason. Because look at the vacuum of our funnel. As you're measuring your soil, I know you may be given a very huge amount of soil. A very huge amount of what? Of soil. And you're not supposed to use it all. Just measure a little. And to me, I'm recommending you to measure only, using a measuring cylinder, measure only 20 mil, we can say centimeters cubed, yeah, it's 20. So you're going to put only 20 there, only 20, so that we see the 20 where they are. The soil should be very dry, like you see. The reason that's why you're supposed to put on a protective gear is that many times even dust is a hazard for you. Like he did, he placed his measuring cylinder on the table so that he can get a very good reading, when it's on the table. So when it's not accurate, you can add to make it accurate and be exact. If you say the 20, use 20. What next after measuring the volume of soil sample X? You said we are dealing with X here first. Place it on the funnel, on the measuring cylinder. We are going to pour the whole stuff on the funnel of the measuring cylinder. Do you know why I used the 20? Because if you use the 50, it would cover the whole funnel. But 20, I'm left with space for the water as the next step. All right, then we are saying measure the required volume of water. For the required volume of water, members, I'm recommending 50 mils. 50 mils. and my brother is measuring 50 mils. 50 mils. I say measure the required amount, volume of water, and add it. Is going to add the water. But now, before you add, there's this stuff here. This is a digital watch. Other schools or other areas, they'll give you a stopwatch. A stop clock, not watch now, a stop clock. So use them very well. And you say add in the funnel the water which you measured on the cylinder X, while at the same time start the clock. After 10 minutes, remove the funnel from the cylinder, then the clock, stop the clock, and read out the volume of water collected in the measuring cylinder. And I want to start. You have first reset. You reset your digital watch, and then on the drop of the first drop of water, you start your clock. There we are. Good. There we are. And it is running. It is running. As it is running, we are observing. We said 10 minutes, but for me I'm recommending 4 minutes. Why? Because you still have a lot to do with this number. So this is our setup. After that, we said repeat. You have to repeat the procedure for item for sample Y. For sample Y. Oh, it has started speeding off, and by now you must be predicting which type of soil is this. Which can allow water to go through it in just a minute? Which type of soil is that? Well, as we are waiting, we are to go to another step, which is data presentation. And data presentation, members, we draw a table, which I've been recommending right from the first place. Draw a table and record your results after 10 minutes of every experiment in all these samples. After 10 minutes, what are we reading? For us, we are using only 4, and it is 1 minute and 35 seconds. So, as we wait, what are we expecting? After 4 minutes, you're going to realize that you have the volume of water, the volume of soil used. We said we used 20. I'm trying to write 20 here. Centimeters cubed. Say, yeah, the units are always there. Thank you. Then 6 units are always there. You put 20. The volume of water you added. What did we add? We added 50. Yes, we added 50. It's the one I'm recommending because of the nature of our funnels. Now, what is the volume of water collected? After 4 minutes, you're going to realize that it is 38. After 4 minutes, 38 milliliters are collected there. Now, what therefore is the volume of water that was retained? It is a simple mathematics. 50 minus 38. And you give the answer. Then, since we said repeat this whole story as it was for sample X, and you said these ones are constants, 20 centimeters cubed. Then here we added 50, and here we are approximately going to get about 15. About 15, and you know which kind of soil will hold the water for 4 minutes to that level. Then what is therefore the volume of water that was retained in the soil. Simple mathematics, subtract the volume of water added minus the volume of water collected. And now, data analysis. What were you analyzing? You compare the amounts of water collected or retained in the two soil samples. What's the analysis? What have you found out? Soil sample retained more water than retained more water. You can't even stop there. Another line, soil sample Y retained more water. Soil sample X drained more water or retained less water. The terms should not confuse you so much. Retaining and draining. Then the conclusion. Soil sample X retained more water than soil sample Y. Therefore, because the retaining, you're basing on the data that you found out. I'm sorry, in my communication I might have mixed up of which one retained, which one drained. But always consider the data, the results that you've found. Which sample has retained what? And which one has drained what? And give what? Explanation. Therefore, soil sample X is the one from Budaka. Since the Budaka pond, this was actually a pond, had adequate water, which means it could not allow that water to go through it. Now that it had adequate water, therefore, it must have been very good at retaining water. Very good at resisting water drainage. Okay, then you continue. Although the Kabunda pond was receiving water from the inlet pipe, most of the water drained through the unstable walls of the pond and through the pond bottom, because the soil type, which is sandy soil, mark this, sandy soil, many learners write sandy soil, and the examiners give scores by massive, cannot hold or retain much water because of its wide air spaces. Recommending for that item previous, members, read through, revise, rewatch this video for that item that we've just left, especially starting with procedures. Others we can try, we can fix it, but many times learners have issues with procedures. Let's have the procedures the way they are. If you have another one which works well and better, but this is the easiest, the simplest, and also the accurate one. Thank you. Now, item 2. This is observational, diagnostic item. The diagnostic in that you have to examine, turn it around, use the eyes, use the ears, use the tongue, talk to it, examine it and observe its behavior, adaptations, characteristic, and then write your findings. Yes, under this item, test item writers have a very large scope to extract the scenario from. However, most times the following areas may show up in relationship to diseases, mark diseases, adaptations, probably what is adapting to what, then damages, and all about. All these may come from tools. And I want to talk about tools. Members, let me even bring you a tool. I have a tool like this one. Yeah, I think this one is seen. You have to look at it very well and tell us its adaptations, characteristics. What are the observable features, characteristics you're seeing, most especially this part. Is it suitable to its function? If this is a knife, what is its function? To cut what? Blade. Is it sharp enough to cut blade? Look at the sharpness. If it's not, then recommend. And the recommendations are as follows. Sharpen. Buy a new. Replace the broken handle. Replace the handle. clean after use, store appropriately. Are you seeing those recommendations? This is a knife. The adaptation, the features, has a handle to ease work while using it. It has a small, slender, and in terms of surface area is not large enough, but large enough to do its work. It has a tapering end to pierce through while being used for its function of cutting, and many more as you're going to revise. This is a knife. The same can work for this. The same can work for this. The same ideology. Okay. Then we have this. This is, we all know this, right? But when you look at it, it is pliable. It can easily turn. You see? It is loosely fitted. Then as you continue to observe, the handle is broken. Then when you look at the blade, is rusty, blunt, does not cut, which means does not suit well its function. Recommendation: fix it tightly. Fix it tightly so that it can tightly fit. Sharpen the blades. Store appropriately. Store properly to avoid rusting. Replace the broken handle. I'm done with tools. Now that I'm done with tools, I want to talk about plants. These ones, many times, they will bring you plants in terms of plant parts. For example, leaves, fruits, seeds, roots, many more. And now, right here, I have some plants. And here, I've brought you cassava. Let me even sit. This one requires me to sit. This is cassava. A band of cassava. Is it cassava? Yeah, you see, potato. It is potato. Now, if it is a bundle, remember this is diagnostic. Look at it very well. There are these ones that have damages. I don't know if you see those damages very well. Then there's this one which is very normal. I feel like even preparing it now. Then we have this one which has cuts. The cuts, if you can see the cuts. Then one which has soil, a lot of soil around it. A lot of soil and even affected. Are you see? Now, after observing those ones, give recommendation how we can get the suitable ones, the good ones. And recommendation is to avoid damages while harvesting, use appropriate tools. A forked hoe is recommended for efficiency when harvesting. Then for the one which has which is rotting, store appropriately. Carry out timely harvesting, timely planting as well. Manage the soil health of your garden. Soil health. You can even spray to avoid the cause of the damages, the cause of the infection or the disease, to avoid diseases or the pests. I'm done. Quickly, I'm rushing quickly like one who's crossing a line of red ants, especially when you're a male. You don't need to wait. Then I have another batch. Another batch. Yeah. Good. I think you have heard the sound of the bell. Have this one. Very low. Not ready for harvesting. I have this one. Let me extend it to your camera so that you can see it very well. Perforated. There is a hole there. And also looks diseased. Yeah. Then I have this one. As a result of a certain fungal attack, maybe bacterial wilt. I had another one which is actually normal. Yeah, these ones are normal. If you mixed them with here, and then we could make a very good meal here. So after observing and rating what you observe, one has holes, one is rotting, another one has a fungal infection, then another one is not ready. As you see, it is premature and it was prematurely harvested. Then there's one which is ready even for consumption. Now, the recommendations are, what do we do to make them suitable for human consumption or for consumption or for use? One, give solutions, suggest ideas of controlling pests, suggest ideas of maximizing harvests, making more yields, adding fertilizers, organic fertilizers of course, carrying out irrigation, mulching, staking, pruning, and many more. Even spraying to control these such pests that can lead to this, and also crop rotation to avoid the fungal diseases. So this item here, it is simply an issue of see, record what you see, and give the knowledge that you have in agriculture, as I've been telling you. Do I have any other that I've not talked about? Probably to go through. So you're going to identify, in case there's a disease, you identify disease. In case it's a pest, you identify the pest. In case it's a specimen, identify it using the observable features. Like this one, it is unaffected tomato with holes. We don't know what caused the holes yet, and it's okay to end at that level. This one is a low tomato, young, prematurely harvested. If it's not on it's plant. If it's not on the plant, it's prematurely what? Harvested. Then this one here, a damaged iris potato. Damaged probably by a pest or during harvesting. Probably by using the wrong tool. Harvest. This one, a knife with blunt blade. A hoe with a broken handle, a blunt blade. Everything which is blunt, we recommend sharpening for efficient use. Now, members, suitability. How do you think, what do you think, suggest ways that could make the particular tool or plant to be suitable for survival, suitable for use, and even for consumption? Suggest, okay, by observing. Now, these ones you're going to read them and interpret them, analyze. Members, in this item, the last item is almost a theory, and I keep wondering, is there really a practical agriculture? Because they would be assessing you from gardens or farm animals or units. But since it is still a classroom practical, you are going to be scored on the characteristics that you've observed, that you've written, the conditions that you've observed and wrote, the symptoms that you've observed and written, and the suitability of that tool, crop, or whatsoever that you've observed and written. Suitability. Then solution is solution is, remember here, if this is affected by a pest, what is the solution? Spray to control the pest. Timely planting, closed season, teaser crops, use mulches, use traps. What else? Use resistant variety. Yes, that is a very pregnant answer. You use resistant variety, but also use clean planting materials. A very pregnant one. Use clean planting materials you're giving solutions to avoid this, and also this, probably also this. All those suggested ideas can work there. Then here, how about this? You harvest at a mature stage. Hey, don't be quick at harvesting premature fruits. What was the other one? There's another one here which has a cut. Yes, I don't know if you can see that cut. Use appropriate tools while harvesting. You're giving solutions. Now, recommendations. On recommendations, what do you give as recommendations? You're giving recommendations on, suggesting recommendations that make the fruit suitable, that make the tool suitable. For example, storing for such a tool, sharpening, replacing worn out parts, replacing broken handles, recommendation, buying new ones, and so on. I request that you rewatch the video, watch it again, share with your friends, don't pass alone, subscribe to encourage me. As you subscribe, you are giving me feedback. That is very important for me. That is my motivation to keep posting. Then the last word that I have for you from my heart is wishing you all the best in this paper. Success. I am the one here swinging, knowing that the air has reached the heart. And above all, my name is called Cornelius Wakala, the farmer. Those are my contacts. They are all both on WhatsApp. In the case of any unsatisfactory issue, and you watched and you're not getting it, please feel free to call, and also WhatsApp. Many times in such a schedule, we are too busy. You may WhatsApp me and I may find the message the next day when you've even done the paper. And I want to apologize to my friends who have done that. You've tried to connect me, to contact me on WhatsApp, but because of the busy schedule, I've been not been in position to address the issues on WhatsApp. Please, I'm sorry. But in case of such a situation, feel free to give me a call. Just tell me the issue and I will attend it to you. I'm free, fair, and available. Thank you so much to my directors, Charlotte, and my country, Uganda. I love you. Don't forget, stay safe, stay away from violence. And my friend can say hi and say bye-bye. Yeah, I said hi and nothing.